Hello, welcome to Astronautics for Exploit. This is Dr. Ayoshola Ogundele. Quantum Internet, the next generation of Internet with potential to transform present-day technological and social paradigms. The focus points are as follows: Quantum Internet futures, Quantum Internet versus Classical Internet, and status of Quantum Internet. The Internet, a vast global system of interconnected computer networks and electronic devices that communicate with each other using an established set of protocols, such as the Internet Protocol Suite, is revolutionizing how humans connect and communicate. In 1969, the concept of the Internet was conceived by the Advanced Research Projects Agency, and since then, it has been evolving. Presently, in this digital era, human lives are woven around the Internet, and the world is highly dependent on it. Some of the applications and services the Internet is providing are the World Wide Web, including social media, electronic mail, mobile applications, multiplayer online games, Internet telephony, file sharing, and streaming media services. Quantum Internet, a secure next-generation Internet with unprecedented capabilities to enable quantum devices to exchange complex and highly secure information in a fast manner, is promising based on its potential abilities to solve complex problems that could not be solved using the present-day classical Internet. Presently, there is ongoing research, experimentation, and development on quantum Internet with the capacity to use quantum teleportation. Attention is focused on quantum Internet based on its ability to provide unbreakable communication. Day by day, researchers and scientists are working to create the world's first quantum Internet. Findings show that researchers have achieved information teleportation via fiber optic cables. This will help in quick realization of ultra-fast and hacking-proof quantum Internet. Quantum Internet is a theoretical network of quantum computers that has the potential to send, compute, and receive information encoded in quantum states. The quantum Internet will provide new functionalities such as quantum cryptography and quantum cloud computing. It will use quantum signals to send information. Illustration of an unhackable quantum data transmission to the Earth from satellite is shown in this picture. The quantum internet is a hypothetical high-speed internet that provides ultra-secure connectivity to quantum devices. Various applications of quantum computers have been theorized and proposed and are under development. Presently, researchers and quantum internet providers are working on ways to make full-scale global quantum internet possible. Illustration of classical and quantum channels is shown in this picture. In collaboration with the existing classical internet, quantum internet will create a coexistent network that can be used to solve specific types of problems. Quantum internet will be useful for solving problems that involve many variables, such as analyzing financial risk, encrypting data, and studying the properties of materials. In this picture, we have an artistic depiction of quantum teleportation between China and Austria. Quantum Internet features. Some of the features of the quantum Internet are quantum bits, quantum encryption, quantum mechanical phenomena, and entanglement. Quantum computers use fundamental units of information, known as qubits, like the bits used in classical computing. Qubits have the capacity to contain superposition of 0 and 1 simultaneously, unlike as in conventional computers. The picture here illustrates measurement device independent quantum key distribution. Quantum encryption is one of the quantum internet features. It is also known as quantum cryptography. It's a cybersecurity method that uses quantum mechanics to encrypt and transmit data. Quantum encryption is based on the physical properties of quantum bits, known as qubits, and the principles of quantum mechanics, which are different from the mathematical basis of traditional cryptography. The picture here illustrates Meteor's satellite, which is named after the famous 5th century Chinese scientist and launched into Earth orbit around 500 kilometers above ground on August 16, 2016. Quantum encryption is more secure than traditional cryptography and could be theoretically unhackable. The quantum internet will use quantum encryption to send information securely. The picture here illustrates quantum commitment scheme. Quantum mechanical phenomena is another quantum internet feature. The quantum internet will be based on quantum mechanical phenomena such as superposition and entanglement. A quantum internet leverages key quantum mechanical phenomena, particularly quantum entanglement, to enable secure and ultra-fast communication by linking quantum particles across fast distances, where the state of one particle instantly affects the state of its entangled partner. Regardless of their separation, it allows for near instantaneous information transfer. Post-quantum crypto systems for Internet of Things is illustrated in this picture. Quantum entanglement is the core principle where two quantum particles become linked, sharing a single quantum state so that mastering one is instantly reveals the state of the other, no matter the distance between them. Qubits can be entangled, which means they share a strong connection. Mastering the state of one qubit will instantly determine the state of the other, even if they are miles apart. Entanglement is one of the features of quantum internet. The picture here illustrates use of quantum artificial intelligence in healthcare and medicine. Quantum internet versus classical internet. The quantum internet and the classical internet differ in several ways, such as information units used, how information is processed, how secure the communication, and the type of computers they are used. The classical internet uses bits, which are either 0 or 1 in classical computing, while the quantum internet uses qubits, which can exist in multiple states simultaneously. Quantum teleportation scheme is illustrated in this picture. Unlike conventional computer bits, which convey information as a 0 or 1, qubits convey information through a combination of quantum states, which are unique conditions found only on the subatomic scale. The classical internet uses deterministic processing, where the transmission changes based on the entire data packet. The quantum internet allows logical operations to change individual qubits without affecting the rest of the data packet. Quantum satellite with solar cells powered by artificial intelligence is illustrated in this picture. The classical internet is vulnerable to hacking and eavesdropping because bits can be intercepted and altered. The quantum internet uses quantum key distribution to establish secure communication channels that are difficult to eavesdrop. The classical internet uses classical computers to process information, while the quantum internet uses quantum computers. Quantum computers can solve certain problems much faster than the classical computers. Illustration of quantum computing in space exploration is shown in this picture. Status of quantum internet. Using lasers in 2017, researchers at the University of Science and Technology of China successfully transmit entangled photons between a satellite in orbit and ground stations more than 700 miles below. Out of every 6 million, the system was able to recover one photon. The experiment showed the possibility of using satellites to form part of a quantum network for reliable communication. Research is ongoing to further the experiment. Quantum artificial intelligence enhancing data security is illustrated in this picture. Transmission of entangled photons. In 2019, scientists with Brooklyn National Laboratory, Stony Brook University, and the United States Department of Energy achieved entanglement over 10 miles using portable quantum entanglement sources and the fiber optic network. In 2020, researchers at the University of Chicago and Argonne National Laboratory successfully tested a 54-mile quantum loop that uses a fiber optic cable. The project demonstrated the core functionality needed for a quantum network line by carrying optical pulses with a delay of only 200 milliseconds. Artist's depiction of China's missile satellites launched in August 2016 is illustrated in this picture. For more information, contact Astronautics for Exploits. You've been watching and listening to Quantum Internet Presentation, that is the next generation of Internet with potential to transform present-day technological and social paradigms, presented by Dr. Anyasola Ogundele, with the focus points Quantum Internet Futures, Quantum Internet versus Classical Internet, and status of Quantum Internet. Thank you.